Hello everyone. So Indrajit here again. I'm going to show you a very short video on one of the questions that I posted few days back. That how do you handle zero values in your dataset? So no, we're not going to drop them because we're going to use those zero values in our modeling. So let me show you what do I mean by zero values in the data set. I'm going to use a bike sharing data set which is available in Kaggle. I have downloaded it, modified it a little bit to suit this video. Let me load the libraries. Okay, I am modeling on my local laptop because it's a basic statistical model, not a high-end heavy model that I'm going to use, which does heavy linear algebra. So let me load my data set and let me go through the data set. Okay, so what do we have here? We have count. So count is the number of bike sharing that will happen or has happened already. It's the historical data, as you can see, and the count data also has zero values. So let me show you a plot. So as you can see, it's not normal distribution. We have a high volume of zero values here. Now this is a discrete Poisson distribution. It's not a continuous gamma distribution. So you could have, if you see similar kind of distribution might happen in gamma as well. However, we cannot use gamma to model Poisson or count data rather. So we will use a specific model which is available in StatMod. So let me go ahead and see how many uh, independent variables are there. We have date and time, okay, seasons, holidays, working days, weather, temperature. I'm going to choose season and temperature, and I have already created the formula below. So there are 4 seasons, and let's me go ahead and run the model. Then I will explain what I'm trying to do or what is the purpose. Okay, let me do the prediction. A root mean squared. Don't get hung up on a bad root mean squared. So let me tell you now what we are trying to do over here. So let's say my use case is using this data, bike sharing data. I am going to model 2 things. One, whether or not using our independent variables I am able to claim uh, whether there will be a bike sharing that will happen or a bike sharing that will not happen. So a logistic regression kind of a modeling, as well as if bike sharing would have happened, how many bike sharing will happen, or what is the count. So as you can see, there are 2 purposes over here, and we are using one model. You could have done it using 2 models, run a logistic regression, set a threshold. If goes beyond this threshold, go ahead and run a regression model or probably a neural network. But that's fine. We can use this zero inflated Poisson regression instead of it. So let me explain a couple of things in this zero inflated Poisson regression. There is something called inflation over here. So what is this inflation? This inflation is the same logistic regression that I was talking about. So internally this model also uses this logistic regression to estimate the parameters. Okay, and also you can see this model has used seasons and temperature, right, as the parent independent variables. So we are using something called a EXOGINFL, and we are setting it to extrain. So what we are saying is, what we are asking this model is to estimate the parameter as a function of the same set of regression variables as the parent model. So the parent model has also used season and temperature to calculate yes or no kind of a logistic scenario. We are telling use the same set of variables and get me a count data or predict the count of bike sharing that will happen. So do not throw away your zero values or zero. If you see a high volume of zeros in your dependent variable and you're trying to go ahead and model that, yes, you can still model that. Don't just throw them off. Maybe that's a pattern that's already there in your data. Having said that, stay safe and signing off now. Thank you for watching my video.